This is section 3.1, which is graphing relationships. So the first thing we're going to do is actually something from your textbook on page 105. It's just an explore activity. So this image shows the distance a delivery van is from the warehouse varies throughout the day. The graph shows the distance from the warehouse for a day from 8 a.m. to 5 p.m. So just to clarify, since this is distance and time, this has nothing to do with the fact that the truck is driving up a hill in any way. If it's going up, it actually means it's going away from the warehouse. And if it's going down, it's coming towards the warehouse. So segment 1 shows the delivery van moved away from the warehouse. What does segment 2 show? So segment 2 is also away from the warehouse, but the only difference is it's less steep, so it's at a slower pace. All right. Part B, based on the time frame, what change in the distance from the warehouse is represented in segment 6? Going towards the warehouse. So in this segment, you're going downwards, which means the distance to the warehouse is decreasing, which means you're going towards the warehouse. In part C, which segment shows intervals where the distance did not change? So segments 3, 5, and 7, nothing is happening. So 3, 5, and 7, we're not doing anything. So time is passing, but no distance is happening. So what is a possible explanation for segments? Maybe they're getting gas or getting food. Obviously, they are taking a break. Or they could be making a delivery. So next is page 106, which is also a part of your textbook. So this represents 3 hoses that fill 3 different water barrels. A green hose fills a water barrel at a constant rate. A black hose is slowly opened when filling the barrel. A blue hose is completely open at the beginning and then slowly closed. The 3 graphs of the situation are shown. So part A says, which graph best represents the amount of water in the barrel filled by the green hose? So if we kind of look back, it says a green hose fills a water barrel at a constant rate. So that would be part B, because it's going up at a constant rate. It's a line. Anytime we see a line, that means it's constant. So right after that, it actually says, since the flow of water is constant, the amount of water in the barrel should be steady increase, thus graph B represents the situation. Describe the water level represented by each graph. So in part A, what is actually happening is the water level for graph A begins slowly and then increases over time. So it begins slowly, but increases quite rapidly, actually. All right, and then describe the water level for part C. It increases rapidly in the beginning because it's going up, and then it slows down. All right, so graph A would represent, let's see, it says we have a blue hose is completely open at the beginning and then slow down, so this would have to be blue. And then for the other one, this would have to be the black one, which is slowly opened and then fills up the water barrel. All right, so we're going to take some notes now on a couple of terms that you're going to need to know. So the first one is a continuous graph. So a continuous graph is just a graph that is made up of connected lines or curves. So in other words, you don't have to lift your pen to create it. So let's say we have a graph. It could look something like this, or if this is our graph, it could look something like that. So it's continuous. It doesn't necessarily mean it keeps going. It just means that we can connect the dots in between. So I'm just going to kind of write the word connected. So think continuous, connected. And then we have discrete graph. So discrete graph is a graph made up of distinct unconnected points. All right, so discrete is disconnected. So a discrete graph could look something like this. So we would have just dots, but I can't connect them. So I'm just going to say disconnected. So we're going to be looking at situations, which would be continuous versus discrete. So a continuous situation could be like filling up a water barrel over time, because I can have fractional amounts of time and fractional amounts of water. But a discrete graph could be something like one bus per 30 passengers, because I can't have half a bus or half passengers. All right, our next term is domain. So domain is all possible x values. So domain and range, what we do is we use them to describe the graph. And then range would be all possible y values. So one thing that students struggle with in general is just knowing which one's which. Like, how do we know domain is x and how do you know range is y? Mainly practice, but one little trick, since domain D comes before R, range in the alphabet, X also comes before Y in the alphabet. So that could kind of help you with that. So we are going to go ahead and practice coming up with the domain and range. So for this problem, remember, domain is all possible x values. So looking at the x values, when we go from left to right, the smallest x value is 1, and the largest x value is 4. So I'm just kind of going from left to right. So 1 to 4. So we're going to actually write it like our compound inequality, which you guys remember from last time. So I know it goes from 1 to 4. I know there's an x in the middle. It's greater than or equal to 1, but it's less than or equal to 4. And those signs will always be going the same way. The other thing is, because they are both closed circles, I'm using equal to. If one of them was open, then that would change it. Now the range is going from the smallest y value to the highest y value. So my smallest y value would be 2, but my highest y value would be 4. So it's between 2 and 4. Okay, now we're going to look at this graph. Kind of a lot going on here. So for this graph, again, go from left to right. So as I move from left to right, it looks like the smallest x value is -1 and the largest x value is 4. So it goes from -1 to 4, x goes in the middle, and because they're both solid dots, I make them both equal to. Now the range, my lowest y value to the highest y value. So my lowest y value is actually 0, and my highest y value is 3. And notice that for the range I put y, but for the domain I put x. Now we have our last one here, which is just a line with arrows at the end. So this means that the line is going to continue forever. So when we classify our domain and range, we don't want to say every single number, but really x can be every single number. And range is the same thing. It's going up forever and down forever. So one way we can say this is by saying all real numbers. And a symbol for that is a big R. So you do 2 lines like this, and then you draw your R. 2 lines, and then draw an R. So whenever you see a line that has arrows on both sides, it's kind of a giveaway that the domain and range will be all real numbers. All right, moving on to our next thing. We have sketch a graph from a description. So we have a student taking a test has 5 questions, which are worth 5 points each, and there is no partial credit. Okay, so we have to ask ourselves, like, what would be the X and what would be the Y? So the input would be the question, and the output would be the points. So we're going to go ahead and set up an L graph because I don't need any X negative values or Y negative values because I can't have negative questions or negative points. We can lose points, but you can't lose more than 0, right? So this would be 1, 2, 3, 4, 5, because I know that there are 5 questions. And then from there, this would be, I'm going to go by 5s. 5, 10, 15, 20, and 25. And this is for points. So, like it says in the question, a student is taking a test and they have 5 questions, which are worth 5 points each. So if they answer 0 questions right, they'll get 0 points. If they answer 1 question right, they'll get 5 points. 2 questions right, they'll get 10 points. 3, 15, 4, 20, and 5, 25. So we can see that it makes a line, but now we kind of have to figure out if this is continuous or discrete. So technically, because it says there's no partial credit, if I connected it like this, then that wouldn't really make sense because that would be saying that if you get 1.5 questions right, you can get 2.5 points, but it's just right or wrong. So I have to leave it unconnected. Now, if you remember back to the other graphs we looked at for the domain and range, it just went all the way across from left to right. So we said it was just between 2 numbers. Now, for this graph, I can't just say it's between 0 and 5 because that would mean I can include numbers like 1.5, 1.6, which is not true. So here's the big takeaway. When we have a discrete graph for the domain and range, you actually have to list them. So for example, the domain is all possible X values, which is 0, 1, 2, 3, 4, 5. And for the range, all possible Y values, which is 0, 5, 10, 15, 20, 25. So again, range is all possible Y values. Okay, so we're going to go ahead and practice with this question as well. A local salesman is going door to door selling vacuums. For every vacuum he sells, he makes $20. He can sell a maximum of 10 vacuums a day. So let's think about this. For 0 vacuums, he makes $0. For 1 vacuum, he makes 20. 2, 40. 3, 60. And then I'm just going to keep going up, but I know that I have to stop at 10 vacuums. So what this actually wanted to do, which I cut off, is find the domain and range. So domain is all possible X values. So let's kind of think about this. Can we say it's just between 0 and 10? If we did that, that would mean that I can have different amounts of vacuums, like 5.5 vacuums, which is not true. So on the flip side, for the Y, which is the profit, I'm not going to get $30 from someone. It's going to be $20 per vacuum. So it's not going to be 21, it's not going to be 19, it's going to be 20. So the only amounts I can get are 20, 40, 60, and increments of 20. So because of this, this would be discrete. So you have to list them. And I'm going to do something like this. So that just means it's going to continue with that pattern until 10. And I can do the same thing for the range. So like 0, 20, 40, 60, and then dot, 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 and it's going to continue all the way until it gets to 200. All right, that is section 3.1.